From Informa Tech Target, I'm Beth Pariseau, and this is IT Ops Query. This podcast distills the signal from the noise about enterprise software development and platform engineering. Each week, we'll talk to expert guests about the latest tech industry news and trends that engineering and IT leaders need to know. Don't forget to subscribe to IT Ops Query for more conversations on AI and the future of the enterprise digital workspace. Paul Constantinides has been an engineering leader at Salesforce for more than 21 years. He joined as a member of the CRM company's technical staff in 2004, then worked as a senior software development manager, senior director of core infrastructure and search development, vice president of engineering leading database and storage operations, senior vice president of engineering leading engineering and operations for the transactional relational database for Salesforce, then finally, as of 2018, executive vice president of engineering leading global engineering for the company's transactional systems and core CRM application. In his most recent position, he leads engineering for the Hyperforce cloud platform as well. Paul, you sound like a busy guy, so thank you for taking the time.
Thank you so much for having me. It's great to be here.
So clearly, you've seen lots of evolution and development at Salesforce over the years. Have there been any consistent keys to success or lessons you've learned about managing infrastructure at scale along the way?
You know, we've had many iterations of our technical architecture, both the infrastructure and the products. But through my entire 21 plus years at Salesforce, trust has always been our number one value. And so building systems in such a way that we can provide the security and availability for our customers that they demand has really underlined everything that we've done, even as we've kind of taken these successive iterations of modernizing our systems and our architecture over time.
Sometimes those are afterthoughts for people who want to move fast and deliver fast. So that's important. So what kind of trade-offs have you faced with those priorities between delivering and making sure you're secure and reliable?
Absolutely. We always want to deliver innovation to our customers quickly, and that's critical. We also want to ensure that we're able to meet their needs, which have evolved over time. We started as a CRM company, as you mentioned. Of course, we still are a CRM company, but the use cases from going from Salesforce automation product all the way to enabling an agentic enterprise where AI agents are supporting customer use cases for our customers for mission critical purposes. That evolution really has it creates a tension, first of all, that you want to go fast, but you also want to provide that level of trust. And so it's created an opportunity for us to really do some interesting innovation and architectural work.
Right. So most recently, in May this year, Salesforce introduced Hyperforce, its next generation infrastructure architecture. What was behind that decision?
So we've been working on Hyperforce for a few years now. And to understand what brought us to Hyperforce, you have to look at the prior generations of our infrastructure. And over the years, we got better and better at managing large-scale data center infrastructure. But at some point, we realized that the public cloud was moving so fast in a way that was introducing new innovations in terms of how to manage systems at scale, how to deploy new architectures rapidly. And it made so much sense for us to take our products and bring them into the public cloud with public cloud native principles. And those principles are really what have allowed us to have things like safe change in our infrastructure, auto scaling, and having things like AI be deeply ingrained in how the infrastructure operates itself.
Yeah, it's really interesting you should mention that and AI because I've heard growing discussions about cloud repatriation in the enterprise over the last 10 years, but some people have predicted pretty consistently the last 2 years that it will accelerate with AI adoption. But it seems like Salesforce has gone the opposite way. Why is that?
Well, for Salesforce, we really focus on the products and the CRM products and the value that we're able to deliver to our customers through the customer 360 suite of applications that we provide. And the infrastructure, there's a middle layer, which we call Hyperforce, where below it is the physical infrastructure that supports the systems, and above it are the applications. And Hyperforce is really the trust layer. Hyperforce is where we can do those things like auto-scaling the systems or recovering when there's some kind of failure, managing the network in a secure and zero trust manner. And really what we realized was that in order to do all those things, we actually need an infrastructure as a service underlying that, and an infrastructure of service that's managed at scale. And that's really what our close partners who are our infrastructure providers are able to do at much bigger scale than we might ever be able to do as a business. And furthermore, the presence globally of our partners is really dramatic. In other words, Hyperforce went live for our customers first in India. It was a few years ago with our first production deployment. And it's a place where if we were to decide to build a data center in India, it would have been a massive undertaking. It would have been a massive investment of capital and operating expense to bring something like that online. And even today, when we look at other places where we have had data centers like France and Germany, we see that the timelines for deploying those data centers and the level of effort to manage and operate those at the scale that we need is probably something that is better done by these partners that we have.
So I'm curious what components are in Hyperforce under the hood. Is it a kind of a Kubernetes cloud native infrastructure automation system, or can you say, what goes into that?
Yeah, absolutely. So we have there's hundreds of what we call foundation services, but you could think of it as supporting everything from the development process, inner loop, outer loop, and deployment with something called managed releases, which is how we deploy safe change into our infrastructure, into through our products at scale globally. It's the kind of infrastructure that allows us to do things like canary and safe staggers, where we can ensure that every change that goes out is deployed in a sequential fashion with validation to ensure that it's working as expected, from lower risk environments to higher risk environments, in that way. And that's something that our customers demand from us. We have a set of security services, so things managing secrets and ensuring that the zero trust architecture is enforced across communication between all services internally and also with customer traffic. And we have, as you mentioned, we have a Kubernetes architecture. Kubernetes-based platform, we call it the Falcon Kubernetes platform, which also includes a service mesh.
I was going to say.
And what that allows us to do is do things like 3AZ deployment of any service automatically. It allows us to have auto scaling of those services and ensure that we're optimizing. So the correct SKU selection of the service on what kind of hardware it should run on to optimize the compute. But then most importantly, also ensuring recoverability. So when we see failures, we're able to continue operating, restarting services as needed, or taking action if we see failures like an AZ failure or a specific service being unreachable or things like that. The system itself has the capability to remediate those issues without necessarily human involvement, and that's something we're really excited about.
Right. I mean, all of those are definitely advantages of public cloud infrastructure. Some people cite concerns about data sovereignty in terms of moving away from public cloud for AI workloads. How do you address that concern?
Yeah, absolutely. And something about our architecture is it actually is an advantage of being in the public cloud is that we have a choice of so many regions. And so
Hmm.
when we hear customers want to be in country from a data uh, locality standpoint, that is something we're often able to provide because we have something like 21 regions for Hyperforce available to our customers. So being able to meet that data regional locality requirement is absolutely something that is an advantage.
So managing infrastructure at that scale, even if you are leaning on a cloud provider for a layer, is a different ballgame, I think. But how do AI workloads and agents change that, if at all?
So with Agentforce, we're seeing our customers deploying AI agents and Agentforce to transform their customer support workload. So 1-800-Accountant is a great example of a customer that's really transformed their support workflow. If you look at Williams Sonoma as well, we talked about them at Dreamforce. They've introduced agents to support the buying process and support process. So it's been transformative. On the infrastructure side, it really changes the game in terms of the load and the unpredictability of load, as well as the mission critical nature of the traffic that's coming in. When we become the face of our customers to their customers, we
Mm.
really take that responsibility seriously. And when there are events like peak sale events or other kinds of high traffic events, it could be a holiday shopping or it could be a holiday travel or something along those lines. We really need to ensure that our systems are prepared. And so we have a set of technologies that we use to predict traffic flow,
Mm.
to proactively auto scale, and also to proactively respond when there are incidents in the system so that we can eliminate the need to do things like manual operations and incident response kind of becomes a post incident activity. In other
Hmm.
words, more and more of the incidents that we're seeing have been auto remediated by the system itself, and that's really a great place for us to be.
So it sounds like an AIOps tool is at work there,
Exactly.
or tool set. Which tools are you using?
So we've built a set of tools
Ah.
internally. Merlion is a open source time series library that we've done in partnership between our infrastructure team and our AI research team.
Mm.
Um, and it includes a time series large language model called Moirai,
Hmm.
which also helps us predict many of the changes in traffic and things of that nature. We have an infrastructure which we call Warden AIOps that allows us to take signals from the running system, actually many different kinds of signals, and actually do a range of activities from remediating things like, detecting high memory usage, and we can, cordon off this app server or restart this process, all the way to authoring an initial RCA document, or what we call PRB, which gives an explanation of here's what happened, here's what we observed, here's what happened, here's the root cause.
Hmm.
And that's obviously not the final version, but it
Right.
gives a language based explanation of the incident itself, which really helps us to go faster in terms of understanding and improving the system.
So what was the time frame for all this? You mentioned a couple years ago you had the first Hyperforce in production. So when has most of this come online and been live?
It's really all coming together now, but
Oh,
the
wow.
work has been underway for many years.
Right.
Warden AI Ops is something that we built initially and used actually when we were running our first party data centers. So it's not something that requires a public cloud. It really is closely coupled with our application services. But these generative AI opportunities and integrating that toward an AI ops and the Moirai large language model, time series large language model is something that really has come about with the advent of large language model technologies, generative AI technologies, and applying it into these infrastructure use cases.
Yeah, I mean, I was around for that first generation of AI ops based on, non-generative, largely
Predictive
machine
AI.
learning.
Yeah.
Yeah. So what has Gen AI brought to the table there that you couldn't do before?
The primary advantage is synthesis of reasoning over many sources of information and generating human interactive kinds of modes of
Mm,
engaging with the system. And so we're heavy users of Slack, and so there's also
mm,
a very heavy Slack integration component to this where we literally have an example of a channel where a team was very actively and intensively monitoring their system, a very critical tier 0 service that we had. And over the last 2 years, we've seen that go from all human conversations to now AI driven conversations where the engineers are being pulled in by the AI when something is seen on the system, and the engineers can ask questions and the AI can provide answers based on monitoring signals of what it's seeing. And that allows us to more effectively really save engineering time and bandwidth for these kind of more mechanical aspects of operating the service.
yeah, I was going to ask next what the outcome has been for those engineers. How has it changed the way they work if they free up this time from the monitoring?
It's definitely allowed us to go faster from a technology standpoint. I would say there are many places where we're seeing AI improving and enhancing the effectiveness of our engineers' skills and capacity.
Mm.
Really, a productive and happy engineering team using the best tools that the industry has to offer, as well as building things that are tailored and suited for our use cases. That's been the most critical opportunity for us. And we have very heavy adoption of AI tools during the interloop kind of development
Hmm.
process. Um, and that's super helpful because we have many code bases across our products. The code bases are very complex, and so having this human and AI partnership to ensure that we're building things in the right way, the best possible way, that's super important.
Right. And you mentioned years of work that went into this. And given your background in database and storage, I'm sure that data hygiene has been a big factor in making these things effective. Would you agree?
Yes, indeed.
Mm.
Absolutely. And so for us, having a scalable observability platform that allows us to have the right level of telemetry into the service is crucial to having these systems work.
Is that also an internally developed tool?
Our monitoring platform uses a range of technologies, some internally developed, some
Mm.
off the shelf. We're heavy users of Kafka
Hmm.
for uh, sending metrics through our system. We may be one of the largest clusters in that regard from the from the point of view of number of metrics that we send through. Um, but it really is closely integrated, and also we do make heavy use of our own internal data cloud. And so the data cloud, which is a product that we provide to our customers for managing lots and lots of data, is exactly something that we use ourselves to operate our systems as well. It provides those underpinnings for managing large scale data.
Right. And then, of course, there are any number of risks and pitfalls to using AI in production. How have you ensured that using this probabilistic technology doesn't lead to, instability in the system.
Absolutely. It's something we are very concerned with, and the remediating actions are typically they are reversible. They are, you could say, fairly, safe or not harmful actions that can be taken. There are, certain kinds of actions that that can't be done by operators, whether they're human or AI, and so to ensure there's a level of safety, we're always erring on the side of caution in terms of what we allow and what we don't. But to operate the service with the availability that we need, really many of the things that had been done typically by humans in the past can be accomplished safely in an automated way with the AI.
How far do you see this going? I mean, do you end up with NoOps as we heard about years ago? Do we end up with, completely autonomous infrastructure, or will there be a mix, do you think?
I think it's absolutely the trend we're heading towards and our goal. In fact, there were a set of principles that we started our Hyperforce journey with, and no manual operations in production was absolutely a critical part of the principles. And what we're seeking to build is an infrastructure, pipelines, ways of doing change safely, and a way of managing operations in the system that really ensures that we don't have any kind of human login or involvement in the running of the system. We're on that journey. We've got a ways to go, but the tools that we have are really proving that it's possible to provide a highly available, highly scalable service, responding to these spikes in traffic coming from critical customer use cases, especially using AI and AI agents, and really excited about that.
Should that world become reality, what is the role for human engineers in that world?
Well, we're definitely writing software, even if it's AI assisted on the writing of software. We're definitely enhancing the state of the art in terms of the scale and performance, the features that we're providing to customers. So we're continuing to evolve our systems, and I think that does require, even if we have AI-based tooling supporting the engineering process, even if we have NoOps objective and limited operator involvement in the running of the system, I think we're still doing that kind of engineering and innovation, and that's really a key part of what we're spending our time on.
Wow. Sounds like you've got plenty to look forward to. Your work cut out for you. So again, I do appreciate you taking the time to chat here.
Absolutely. Thank you so much.
Thank you for tuning in to IT Ops Query. To learn more about enterprise software development and platform engineering, explore our content on Informa Tech Target sites. Find us on YouTube at our channel, Eye on Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Thank you for joining us.